Hello. Today we will solve the following radical equation. A distinctive feature of this equation is the presence of two types of radicals, square and cube roots. The solution can be found using various methods, and I will demonstrate one of them based on what is known as double substitution. Specifically, we will introduce two new variables, u equal to this cube root and v equal to this square root. At this point, I recommend pausing the video, attempting to solve the problem on your own, and sharing your answer with us in the comments. I am giving you a hint. This equation has three roots. When you return, we will continue working together. Let's continue. First, we replace the radicals with new variables. At this stage, you might ask, what is the advantage? We have ended up with a single equation with two unknowns. It is impossible to solve. You are right. However, we can proceed as follows. We take the definition of variable u and cube both sides to obtain an equation of this kind. Next, let's do the same with the definition of variable v. We squared both sides. Now we have a system of three equations with three unknowns, u, v, and x. And we can solve this system. How to do this? First, let's eliminate the variable x between the second and third equation by adding them together. On the left-hand side, we get u cubed plus v squared. On the right-hand side, we have just 9. Then let's bring in the first equation, and the result is a system of two equations with two unknowns, which can be solved. Let's solve this system. What do you think we should start with? Yes, from the first equation we can isolate v. Let's substitute to the second equation. Expand this term. Cancel out the nines. And finally, let's factor out u. This equation is easy to solve, and we will do this right now. Here, the product of the two factors is 0. This means that at least one of them is 0. Let's start with the first. We immediately get the solution, u equals 0. Now let's set the second factor equal to 0. We obtained a quadratic equation. You can solve it yourself using Vieta's theorem, and please tell me the answers. Yes, you are right. First solution is u equal negative 3, and the second u equal 2. To find v, we can use the formula which we obtained previously. V equals 3 minus u. But we don't actually need to find v, since we can find x using the values of u we are already found. Don't forget that our goal is to find x, not u and v. Let's find the values of x. We know that u equal cube root of x plus 8, and that the equation in terms of u has three roots, 0, negative 3, and 2. Consider the first root, u equals 0. From here we have cube root of x plus 8 equals 0, and as a consequence we have x equal negative 8. In the case when u equal negative 3, we have for this cube root -3. Cubing both sides, we obtain x plus 8 equal -27. And from here we have x equal -35. For u equal 2, we have cube root equal 2. Cubing, we get the following, and x from here equals 0. Thus, the original equation has 3 roots, these 3 numbers. All that remains is to verify these roots. The simplest way to verify a root is to substitute it into the original equation and confirm that the equation holds true. Today, however, we will employ a more general method. We will determine the domain of the original equation and verify whether the roots we found fall within this domain. Let us analyze our equation to identify the possible real values of the variable x. The first term, the cube root, is defined for all real values of x. However, the square root is defined only if its radicand is non-negative. This condition is satisfied if 1 minus x is non-negative. Thus, the domain of the equation is determined by inequality x less or equal 1. All the roots we found lie within this domain, thereby confirming their validity. Now we can write the final answer, and our problem is solved. As a homework assignment, allow me to pose a question. Does a solution to this equation exist within the realm of complex numbers if we extend the domain beyond its original boundaries? I look forward to reading your answers in the comments. And the last thing, if you find this video useful, please help us in our work on this video. You can do this with likes, subscriptions, and comments, positive or negative. Thank you for your help.